Okay, hello everyone. This is the final video on indices and it is about surds. Now, a surd is an expression that involves your root, example square root or cube root, fourth root, etc. The purpose of a surd is to find a simple way to express an irrational number, which is basically a number with decimal places that go on forever. So, for example, square root of 2 is 1.414 and keep going on for eternity, and so we use surds to represent them. Now, rule 1 of surds says that the root of xy is equal to root x root y. So a way to show this would be that you take root 6 and split it up into root 2 times root 3, and so root 6 would be equal to root 2 times root 3. And you can go ahead and test it on your calculator and you'll see that it's true. The next one, your next rule says root of x over y is equal to root x over root y, similar to the first one but the division. And the most important one is, let's say for one more of a common mistake, the square root of x plus y is not equal to root x plus root y. That's a common mistake, but it's incorrect. You can go ahead and test for yourself. If there's a minus here, same thing, it won't work. They have to be joined by a multiplication or division for this to work. Go ahead and try some problems. Also, simplifying surds. Now, when you simplify a surd, you want to get it down to factors involving the smallest possible number under the root sign and with a multiple out here. And the way to do that is, for example, if it's a square root, you will express the number under the root sign as factors of its highest possible square number under another number. So for example, root 80, we could express 80 as 16 times 5, so we could say square root of 16 times 5, highest possible square number times the other number to get back to 80, and we could rewrite this as root 16 times root 5. Now root 16 is 4, so this becomes 4 root 5. Now, when you're doing simplifying an entire expression, you want to get the same number under the root sign for each of them, so you can add and multiply them. The only time you add and subtract them, the only time you can add and subtract surds is when the same number is under the root sign. So we could change the 180. We could divide 180 by 5. And we would get 36. So we end up with 3 square root 36 times 5. And based on what we did earlier, this should be 3 times root 36 times root 5, which would give us 18 root 5. Then you can go ahead, divide 320 by 5, and we get root of 64 times 5, which would give us 64 times root 5, which you know root 64 is 8, so this would in turn give us 8 root 5. So now we would have 4 root 5 plus 18 root 5 minus 8 root 5, and we would just subtract and add to give us 14 root 5. Let's go ahead and try this one. This one has variables as well as numbers, so it might be a bit more challenging, but just try to stay focused. So here we can immediately go ahead and split this up into root 320 times root x cubed plus root 125 times root x cubed. Then we can search again for the highest square number and the other number that we get about the 320. Based on what we did earlier, we could assume that that's 64 and 5. And then we can see that this would bring us to a common surd, as 125 divided by 5 would give us 25 times 5, and 25 is a square number. So here we can go ahead and write this back as root 64 times 5. This can be written as root x squared times x plus root 25 times 5 times root x squared plus x. Alright, you can go ahead and put this as 8 root 5 times x root x plus 5 root 5 times x root x. And of course, you know, based on last surd, we can multiply these two under here, so we can end up with 8x square root 5x plus 5x square root 5x. So you know we have a common surd, and we can just add like regular, so we can just say 13x root 5x. That's simplifying surds. Now there's another concept in surds known as rationalization, and it involves getting rid of a surd under either in either the numerator or the denominator. The one we'll be doing here now is rationalizing the denominator. Now, if you have a surd like this, which is 4 over root of one number, to rationalize it, you multiply this, all of this, times the surd upon itself, because this time this is 1, so it doesn't change the value, but it will end up changing where we have the surd. Multiply this, you'll get 4 root 5 over root 5 times root 5, which will just be 4 root 5 over 5. And so we did it, we rationalized the denominator. The purpose of rationalization is to change where the surd is. So we took it out of the denominator and put it into the numerator to make it easier to work with. This one will become similar with x, and that will give us 2 root x over x. Now let's go ahead and try one where it's a number minus a surd. Now if you want to rationalize this one, you have to multiply it times its conjugate. The conjugate surd, for the conjugate surd, all you have to do is flip the sign. So if this surd is 1 minus root 5, you multiply all of this times 1 plus root 5 over 1 plus root 5. Of course, you know, this will give us 4 into 1 plus root 5 all over 1 minus root 5 into 1 plus root 5. Then you would just multiply it normal and you'll end up with the answer right there. And that's surds. Here's another example. 2 over 1 minus root 3. So this one we would just find the conjugate, which is 1 plus root 3, and just say 2 plus 2 root 3 over 1 squared minus root 3 squared, as you know, difference between two squares. And of course, that will give us 2 plus 2 root 3 over 1 minus 3, 2 plus 2 root 3 over negative 2, and you can choose to go through by 2, so that would give us negative 1 minus root 3, and that will be our solution for third. Here we go.